Okay, so I'm first going to go through a motivation of why we want to use Open On Demand in the first place. Then I'll look at what it actually is and go through the main features of it. Then I'll look specifically at our Open On Demand portal at SciNet. I'll go through multiple demos of Open On Demand, and I'll get you to try them out as well. And then in the second part of the talk, I'll look at our job submission and monitoring tool with Open Composer, which is inbuilt into Open On Demand. Okay, so the idea behind it is terminal-based interfaces can be pretty daunting for brand new users. If you've never used the terminal before, if you're a Windows user and you haven't used Linux or Shell or anything like that. So we need a way to make HPC more accessible to new users and improve the learning curve and the introduction to HPC. So a good way to do this is with web-based interfaces. So this is all access from your browser, so in Firefox, Chrome, Safari, depending on what platform you're on. There are many different options available. So you might have heard of JupyterHub being a very popular one. There's also Galaxy. There's RStudio. But today we are going to look at the Open On Demand implementation of this interface. So what is Open On Demand? So it's a web-based interface that provides you access to HPC resources. It was an open source project developed by the Ohio Supercomputing Center in 2017. It was funded by the National Science Foundation and is now nearly 9 years on. It is worldwide with over 400 HPC centers. And in Canada specifically, we have deployments at SharkNet for access to NIBI, as well as Vulkan at the University of Alberta through the AMI Institute. And then we also have GREX, which is the system at the University of Manitoba. But we also have systems in the US, so in Pittsburgh, Purdue, and also Expanse in San Diego. But it's also across the pond in Finland at the Lumi Supercomputing Center, which is where I first found out about Open On Demand. So it's used everywhere. There's a big open source community which are constantly contributing to this project, and it is growing rapidly. So the idea is, yes, it's supposed to make HPC more accessible to users with no experience with HPC beforehand. It's built with Ruby and JavaScript, and it provides a graphical interface to computing resources as opposed to just command line interface. And it's a great tool for teaching and learning HPC skills incrementally rather than being thrown in at the deep end with the terminal. You can dip your toe and see if you can use the terminal open on demand, but you don't have to. You can use all of the graphical elements to the interface. And yeah, it lowers the barrier to entry for new users who may be intimidated by the command line interface. And you can even access it from your mobile phone because it's any browser can log into Open On Demand. And you can check, running jobs, you can start new jobs anywhere you like. So yeah, this is just a map of all of the deployments of Open On Demand across the world. So as you can see, it's spread out rapidly since its creation nearly 10 years ago now. Okay, so I'm going to go through the key features. So are there any questions before I continue? Okay. So as I said, it's web-based access. You One of the nice things is you don't need to install anything locally, so there's no specialized software. All you need is a browser. And another big thing is you don't need to configure your SSH keys or SSH connections like we normally do on Trillium, where you have to create an SSH key, copy the public SSH key to the CCDB database, which then gets copied on Trillium, and then you need to use your private key when you log into Trillium. This is one of the biggest uh, hurdles for new users accessing our systems, and I think, yeah, it's the biggest number of tickets that we receive are due to SSH keys. So this completely does away with any SSH configuration from the user standpoint. But as you can see, once you log in, you have a nice browser interface here, and you can see message of the day. You can see any links to our quick start guides, and we'll give you some updates on the recent changes to Open On Demand. And then you can see a list of apps that you can access from Open On Demand. I'll go through more of this in the demo, but this is the interface that you'll see after you log in. You can also submit Slurm jobs to the Trillium scheduler from Open On Demand, and it makes it much easier to submit, monitor, and manage your jobs from Slurm standpoint, all in Open On Demand. So you can easily create and customize your jobs using a basic web form rather than creating your Slurm scripts from scratch in the terminal. Again, I'll go through this in more detail later on. From the job monitoring standpoint, you can access the in a terminal with when you want to access Slurm, you need to use commands such as sq, sbatch. With this active jobs page, you can see all of the jobs that are listed on the cluster that are either running or have just completed, or you can look just specifically at your jobs. And you can see if they're still running, which nodes they're running on, how many cores they're allocated, how much time do they have left. A whole bunch of job information can be displayed on the interface there. Another big part of Open On Demand is the file management. So you can access all of the Trillium file system from Open On Demand in the browser. You will have a list of shortcuts, so you can access your home directory, your Scratch, and any project directories that you have. You can edit the files directly in the browser. You can upload new ones. You can download the files locally to your laptop if you need to. And you can also create new files as well from this interface. This is all handled by the file manager. But one of the biggest things is you can run what are known as interactive applications. So these are things like Jupyter notebooks, RStudio servers, VS Code servers, or you can even run a desktop in Open On Demand. And this makes it very useful for data analysis, visualization, and any other forms of interactive compute. And the way you do that is you access it from this submission form. You'll ask for the number of hours, the number of cores that you need, and how much memory. You'll hit launch. Everything in the background will be handled for you, so that the job will be launched, and then you'll go to a window which will show you how to connect to that application, such as Jupyter. But again, I'll go through this in a demo later on. And the whole suite of applications that are supported by the Open On-Demand community is growing every day. We only have a select subset of applications on our Open On-Demand deployment, but if you have a need for any new applications that are not there, please don't hesitate to contact us. We can install it and we can work with how your workflow how it progresses. This is where the open source community comes in as different developers will add new applications, but then they'll upload them to what is called the Open On Demand appverse. So I can then pull from there and develop a local working version at SciNet. As I said earlier, we also provide shell access via Open On Demand, but you can do this directly from the browser. So this you can sort of try out shell commands if you're not familiar with it, but you don't have to use it. It's there for users who maybe have transitioned from using the terminal and they find Open On Demand easier to use, but you can use the terminal from inside Open On Demand. Okay, so are there any questions so far before I move on to the next part? Okay. So SciNet's deployment. So we've been live since December 2024. We did a sort of proof of concept initially. We had a couple of users, and then it's been steadily growing since then. And as of April 2026, we have roughly 180 weekly active users on our Open On Demand platform. So it's grown in popularity over 2025, and the numbers are steadily growing up. So yeah, provides access to the Trillium HPC cluster, which includes Trillium GPU as well. And you can access it by going to our portal at ondemand.scinet.utoronto.ca, where you will need to have an account on Trillium to access it. And the login credentials are the same as what you use as your Alliance account. MFA is enabled, so you'll be prompted to authenticate with Duo once you've signed in, or as you're signing in. And we have a quick start guide on the Alliance wiki here. So that'll get you up and running if you have any issues. But more recently, I've deployed a new Open On Demand portal for the Teach cluster. So any instructors can use Teach through Open On Demand now without having to worry about, as I said, SSH keys, the initial setup phase. And you can access that from ondemand-teach.scinet.utoronto.ca. So this is just single factor authentication as Teach is normally. So it's just your username and password, but you need to get an account on Teach in order to access this platform. So we currently have the following setup on our portal. We have the file browser, we have job submission and monitoring, and what we also have is the module browser, which lets you look at all of the software modules available on Trillium and to see which modules are needed to be loaded before loading the module of choice, so all the module dependencies. So you can just copy and paste from this app in Open On Demand into the terminal or whatever script that you need to run directly. You can also look at your storage quotas to see how many files you have on home, scratch, or project, as well as how much data storage you're using up, and if you're hitting that limit. You'll also get a warning when you log into Open On Demand if you are, I think it's 90% of your capacity, just to make you aware of how much storage you're actually using up. So yes, we also have the shell access to Trillium. Then we have JupyterLab apps, RStudio servers, VS Code servers. You can access remote desktop, remote on demand. Then we have Paraview. We'd recently added MATLAB because we have a license now from the University of Toronto. And we also have access to a debugger called DDT and a subsequent profiler called map. And we have some licensed software. So if you have a license for Stata or SAS, you can also use it Node on demand. We just need to know ahead of time and we can set that license up for you. So all the applications that are provided here are through the software stack available on Trillium. But again, we continuously add new features. So if you need a new application, what is not there, just let us know and we can add it for you. Okay, so now I'm going to go through the resources behind Open On Demand and the nodes that we have available. So we have a separate set of nodes for Open On Demand because these are for interactive jobs. So we have a separate scheduler, separate Slurm scheduler for the OOD jobs. If I say OOD, I just mean Open On Demand because it's very long to say that every single time. And so we have 65 nodes set up for OOD. And each node has 40 cores and 180 gigabytes of memory. But OOD 1, 2, and 73 are what we call large memory nodes, which still have 40 cores, but we have a terabyte of memory there. So if you have any larger jobs that need more than, I think I set the limit to 85 gigabytes, then you can run your jobs on the large memory nodes and you request up to 500 gigabytes of memory. The whole cluster is scheduled by core. Because we're running interactive jobs, we're not always going to be utilizing all of the cores. So we have scheduled by core. And this is different to Trillium, where everything is scheduled by node. So when you ask for one job on Trillium, you'll get a whole 192 cores and 755 gigabytes of memory. So I just want you to make that distinction
I have
between,
a
yeah,
question
yeah,
then about the large memory nodes then. So
yeah.
those ones also scheduled by core, and you can have up to half a terabyte of RAM.
Yes, that's correct.
So you're not like, are you like, sorry, do you have to, can you ask for up to 40 cores, even though there are only 40 cores on the node?
So I've limited to 20 cores so
Okay,
that
yeah.
we can at
Yeah.
least get two users on for the full memory.
Okay. That makes sense. Okay.
Yeah, because we only have limited numbers of high memory nodes, so to make it available for more users, I have to limit it that way.
No, that's great though. That's a nice ratio.
Okay,
Thank you.
thanks. And yes, per job you can request how much memory you need. So from 1 gigabyte all the way up to in the standard queue is 85 gigabytes and 500 gigabytes in the high memory, large memory queue. As they're interactive jobs, we have a 3-day time limit. So you can start a job on Monday and you can come back Wednesday if you want to, and it'll still be running. Again, this is different from Trillium, which has a 24-hour time limit because that's better for scheduling on Trillium, but for OOD, we have a 3-day time limit. Yes, it said 20 cores max per job, and the default queue allows up to 85 gigabytes of memory per job. And the high memory queue is 500 gigabytes of memory, but also it's only one job per user. So that stops users taking all of the 3 large memory nodes up at a time. But we've recently added a GPU node to the Use cluster, and it's just one node. But that one node has four H100 80 GB GPUs, and just this one node has 96 CPU cores and 810 gigabytes of RAM, CPU RAM. So what we've done to increase the capacity of this one node is we have created, well, we've enabled MIG on the node, which stands for multi-instance GPU, with the H100 1.10 profile. So what this means is this one node of 4 GPUs actually provides 28 GPU instances, where each instance provides 10 gigabytes of memory each and 1/8 the compute resources of a full H100 GPU. Because this is interactive compute, the idea here is you can run some tests or run some small jobs on this GPU. And then if you need the full capacity of a H100, then you can run on Trillium GPU um, to fulfill the full needs of your job. And the way we've cut this up is each job always gives 27 gigabytes of CPU memory and 3 cores per GPU instance, just to keep it even across jobs uses. But I think you can have multiple GPU jobs running at the same time, different to the large memory queue. So, are there any questions about that before I move on to the demo? Okay, so I thought I would just give a quick demo of how you log into Open On Demand. Can everybody see my browser? Okay,
Yep.
good. So we'll just go to the address here. I'll take you to the login. So you'll log in with your Alliance details. It will ask for a jaw push. And it'll log you into the interface. So as you can see, we have straight in with a message of the day. I'll just give you a brief introduction where we have a regular maintenance window, which is every Monday morning between 7 and 8 a.m. We'll have links to our quick start guide, system status. My SciNet is just for monitoring job performance. And then we'll give a brief update of each week what we're improving to Open On Demand. It'll give you a section on your recently used apps. So what you can do from here is you can launch your interactive jobs instantly by just clicking on the app here without having to go through the form. But I'm going to go through the interactive apps shortly and show you how to do that. These two windows are also collapsible if you want to remove them from your view. But then also at the bottom, we have a list of pinned apps that you can access. So I briefly talked about the module browser here that you can see, and then you have shell access to both Trillium and Trillium GPU. And then we can look at the file browser from your home directory and look at your storage cores. And then we'll have the whole list of interactive apps all from the front page. So if you want to create a new job, you can just click on here and go through the form. Then this is the Open Composer I mentioned earlier, and these are the templates. So you can launch Open Composer with a specific template for MPI, say, or R or Python. You can go directly from the front page here. And we also view the active jobs on the cluster. So what I was going to go through is just look through each part of the page here. So along the top, we have the navigation bar. If you click here, it just takes you back to the front page. And we have a list of all of the apps here. And then you can click here and it'll take you to a page where we can increase, and this will show you all of the apps. I have double the number of apps here because I have like a sandbox app, so I can develop apps separately from the main branch of apps. But you can see them all here. And the next tab will have the file browser. So in here, you can access your home directory. You can see all the files. You can, let's just pick, yeah, let's pick here. And you can view the file directly in your browser. If you want to edit the file, you just click edit, and that'll open sort of like a Vim or Emacs kind of view, so you can edit the file here. So we can save that. And then when we go back to the file, it should have saved in, yes. So I'll save it on the Trillium file system directly. Oh, we have somebody back in the, okay. Ramses, are you able to disable a waiting room? I just had to admit somebody.
On it.
Thanks. Thanks. Where was I? So what you can also do is I can download that file as well locally. And we can also rename, delete everything you want to do. You can also upload files. So I can just drag and drop a file from, let's just pick, and then upload it directly, and we can see, yeah, so we can see the file there just added from my laptop. Another good feature is the Globus. So I don't know if you're aware of Globus, but it is a file transfer tool that allows you to move files between different Alliance systems. And if you have it set up on your laptop, you can move files from your laptop to Globus and to different clusters in the Alliance. So what if I click here, it should ask you to, you'll sign in with your Alliance. And because we already signed in to the Alliance when we logged into Open OnDemand, it automatically logs us in to Globus, and then you can still see the same files here. And if we change to Scratch, as we have a directory shortcut list here, and I click Globus again, it'll open the file browser exactly where you are in OOD in Globus. It's a nice little feature there. But as I said, yeah, we have a list of shortcuts of files here of different directories. You can also create new directories, new files, just give it a name. What we can also do, I'll move on to the next part, is the terminal. So you can open the terminal in a given directory just by clicking this. So this will open the file on a login node on Trillium in that given directory. So we can see we're in home here. What else do you want? So come through all that. You'll also notice in the files navigation, we have storage quotas. So if you click on this, this will show you how much space you're taking up on the file system, what your total capacity is, what percentage you're using up. So this will give you the data storage, and then this is the number of files, because you have quotas in both data and maximum number of files you can store. Again, this will show home, Scratch, and your project directories. Oh, and I think it's sorted by your maximum capacity. Yeah. So the idea here is if you run out of quota, you can see which directory it's under, and then you can go to the file browser and find out what files are taking up the most amount of space. The next section here will show you all of the Open Composer templates. I'm going to demo that later, so I'll not go into it now. But we also have active jobs. So this will show you all of the jobs that are running on the cluster or you have queued. I just need to hide my Zoom. Okay. So you can see all of your jobs which are running on all of the clusters, or you can look at everybody's jobs running on the clusters here. And if we just pick a random one, we can see, okay, so this Trillium by core, so that means that it's actually running on OOD. And we can see how many cores they have, what nodes they're using, how much memory they have, and when the start and end time was, and the output location as well. So you can use this app to monitor your jobs if you need to. You can also, so if you went to just my jobs, you can also cancel your jobs from this view if you'd like to. And you can change the clusters as well. So we can just look at Trillium, we can just look at Trillium by core. So that's Open OnDemand nodes. And also Trillium GPU. Okay, the next section. So we have the clusters tab. And I just briefly touched on this earlier. You can gain shell access to Trillium if you want to, all from this tab here. So we can look where we are, we can look at the performance of the node, see what the cores are doing, how much memory is used up. Anything you like through the shell access. So we have that for Trillium and Trillium GPU. The module browser, so this is showing all of the software available on Trillium. So if we look up, of course, this is not working now. This was working the last time I checked. No. So this should be working, but it's not. And I'm just finding out now. It's not. Anyway, I need to fix that because that should be working. Anyway, the idea is that you search for a module here. Actually, I don't know if I can show you a screenshot in a quick start. So this is what it should look like when it's working. You'll search for a module and it'll give you a list of the versions of the module, and you can click on the version and then you'll see the dependencies that it has, and then it'll provide a module load command which you can copy and paste into a job script or even directly into the terminal to load that module, and then you can start using the module. Well, apologies for that. I don't know why it's not working. Okay, so there's also a tab here called System Status, which will show you the load on the cluster. So how many jobs are running, just like a very top level view of what is happening there. It just takes a little bit of time because it's querying slow. So as you can see, so the Trillium by core, this is the OOD cluster. And then we have Trillium GPU and the Trillium cluster. So as you can see, these are very heavily used, nearly 100% of the time. Whereas OOD still has capacity for more jobs. So you'll almost always get a job instantly on the OOD cluster. versus Trillium or Trillium GPU, I'll have to wait a little bit of time. Okay, so for the interactive apps, which is the main use of OOD, if we go to the JupyterLab app, I don't know why it's thinking about it. You can go from here as well. This will take you to this page here, and you can see that which queue you want to submit from. So the default is the standard nodes, or you want the high memory nodes. This is for jobs greater than 85 gigabytes. You can select the number of hours, so you can just increase that here, or you can just type in a set number of hours. And then here you can increase the number of cores and how much memory you want. And this is where you select if you want a GPU or not. So if you select a GPU, you can't run on the high memory queue, and you can't select the number of cores on memory because you're automatically assigned 27 gigabytes of memory and 3 cores when you request a GPU.
In your example, you mentioned that like you could start on Monday and come back on Wednesday if you had it for 3 days. Do you have to set the number of hours to be 3 days
Yeah,
long then?
yes, that's
Okay.
correct. So you just
Okay.
set 72. So if I set 73 here, that shouldn't. Yeah, so you'll get an error saying the most amount of time is 72 hours, which is 3 days.
Okay. So if I only needed it for 3 hours and then I found that actually I needed to finish something up in 4 hours, it would have cut me off the
Yeah,
job.
it'll kill the job after 3 hours, and then you can just start a new job again.
Yeah. Okay.
Yeah. The same goes for the memory as well. I think I limit to, I think it's 85. So if I try increasing, yeah, it doesn't let me increase the amount past 85, that limit that I've set on here. I'll go through a quick demo of JupyterLab. Well, actually, no, I have another demo of JupyterLab. I just want to show the interface and how you would launch jobs here. But we have, again, up on the left-hand side, multiple different apps that we can go through. So we have RStudio, Trillium Desktop is also popular, all from the interactive apps navigation here. Oh, we have a question from Beth. You may have already covered this, but can you see job start of your job afterwards? So this is after the job is completed, or is this while the job is running? Because you can see the running jobs from the active jobs list, but after the job is finished, you won't see it in that list there. But on the next page, you'll see a whole list of all of your completed jobs. So you can look at if the job fails for whatever reason, you'll look at the output log and you can see the code that was running, and you can see the output from Slurm and if there was any issues with the job. I hope that answers your question. Because what you can also do from this page is when a job is running, you'll see it running here and you can connect to it. But you can also delete the old session cards from old jobs, and you can also relaunch the same job again with this little button here. Another nice feature, I'll go into that in a later demo, but that is essentially it for this demo. I want to go through front page. Oh, yes. So we also have a link to the quick start and the documentation here. And if you click that, that should automatically open up you in your email client, and you can submit any problems or tickets that you have to us, and we'll get back to you. And I'll have links to the Alliance Wikipedia page, and then just who you're logged in as and the logout options there. Anything else I wanted to go through? Close terminal module. I think I went through everything. So the first hands-on, all I want you to do is I want you to access the UTPOL using your Alliance credentials. And I want you to just explore the dashboard and familiarize yourself with it. Use the file browser, upload a file, create a directory, and edit a text file just to get a feel for it. And then open a terminal session and run some basic commands. The module browser I thought was working, so you don't have to do that. I don't know why it's not working. And you can also check your storage quarters. So it is nearly 10:50. So if I can get you to do that now until 11 o'clock, and then we'll continue with the talk. But me and Ramses are here to answer any questions that you have while you're going through the hands-on. I hope everybody was able to log in and get used to the interface on Open OnDemand. Sorry about the module browser. I'll try and fix that after the talk. Okay, yeah. So I'm just going to move on to another demo where we'll look at over here. Okay, so we've just logged in. I guess some of you've already tried a JupyterLab. You'll go into the interactive apps. You'll click here, and then we'll ask for just whatever is here. So a couple more gigabytes of memory, a few more cores, and this is also useful if you want to receive an email when the session starts, if you're not at your desk when you launch the job, and it's queued rather than launching straight away. We'll hit launch. And then you'll be taken to the My Interactive Sessions page, where you'll see all the interactive apps on the left-hand side. I have extra here again, but this is my dev environment. So these apps I can also work on. And then once the job started, we can see we have requested one node. Again, because it's hyperthreading is enabled, it shows 8 cores here because that's how Slurm sees the node, how many cores. You see the job's running. We can see the host that it's on. We can even click here and it'll give you a shell session to that node. But you can also use the Jupyter interface to open a shell as well. This here is the session ID. So each job has a unique session ID and it's saved into your Scratch directory. This will take you to the file browser and it'll show you just a bunch of scripts that are needed for the job to work. But we have a quick link to the output log. So for whatever reason your job fails, you'll go to the output log and see what went wrong. Or if you send a ticket to us, attach the output log and it'll make it easier for us to diagnose the problem. We can see the number of physical cores requested, how much memory we requested, and whether we got allocated a GPU or not. Then you'll hit the connect button, and this will take us to a JupyterLab session. I'll ask us to select a kernel. But again, if you've used Jupyter before, we have a file browser on the left-hand side here. And it should be favorites to your home project in Scratch. And on the left-hand side, there's just some useful plugins for JupyterLab, but the one at the bottom is probably the most useful. And this will show all of the available modules. So this should have been shown in the module browser in the Open OnDemand interface. But what you can do is if you need any software loaded prior to you running a Jupyter Notebook, you can load it in here. So for example, if I want to run the SciPy stack, I can load it here. and it'll show the loaded modules, and then that'll be available in your environment in a notebook. You'll have to, if you have a running notebook and you load a module, you'll have to shut down the kernel of that notebook and reopen it to be able to see the modules because it doesn't quite sync. You have to change that. So I've just created a script to plot a sine curve, and then we'll just run that, import NumPy and Matplotlib, which is installed by default on the Ute compute nodes, and then we'll just plot it. As you can see, you can access everything from the browser here. If you click a new tab, we can see that we can launch a new notebook with a given kernel. If you want to set up your own environment with your own packages, what you can do is create a virtual environment with a given Python version, activate the environment, pip install the packages that you need, and then in order for it to work in Ood, you have to run a command called venv to job. And what that'll do is it'll add the kernel to the Jupyter interface so that it will appear in the list of kernels to show here. What you can also do, and then when you import packages, it should be from the virtual environment that you created. Yeah, you can see the kernel here, what's currently running. So that is, and then also you can just open a terminal in JupyterLab and you can look at what is happening on the node. Again, I think, yeah, it shows you the whole number of cores. As you can see, there's another user running on this node, and you can see they're using X amount of cores, but then you already have the 2 cores allocated for the job, so that won't step on the other user and vice versa. You can also start, I think it's an R kernel inside Jupyter if you'd like, but we also have RStudio as well, so that's mainly for our stuff. I'm trying to think, is there anything else in Jupyter I wanted to show? Oh, there's a dark mode in JupyterLab. I don't know if you're aware of that. That comes in handy. I prefer all of my browser windows in dark mode because I find it too bright. There's one other feature of Jupyter I wanted to show. So if you can just cancel the job if you finish with it. So I just showed you the JupyterLab, which is installed by default on the nodes, but there is also a JupyterLab environment in the Alliance software stack. So if you start a Jupyter job by checking this box and launching that, so all that's happening in the background here is the Slurm commands are being executed on the cluster for you, and then it provides you with the connection to the job here without you having to execute any sbatch or sq commands. So if we connect to this JupyterLab, this looks slightly different. So it'll still have our same kernels, but if we open a new tab, we'll see we'll have access to RStudio desktops and various other software and Globus here. So this is another way, I guess, to access Jupyter and the other types of software. So you can see, so if we load, try to think of an example of what's not there. If Paraview is there. For some reason, Paraview is not an option. But if there's another piece of software that you want to, you can load it here and you can start it from Jupyter. just sort of like two steps to accessing the app, whereas you can just access it directly from the Open On-Demand interface rather than going through JupyterLab. But the number of modules is more extensive here from this JupyterLab. So if we wanted to open the mid desktop, you can do it through the Jupyter interface. But that means you need to start a Jupyter job and then start the desktop. What I'm going to show you now is just how to do it straight away from Open On Demand. So we have that job on, we can just leave it running. Oh, actually, yes. So I will show you the GPU. So if we want to ask for a GPU, we can just select it from the drop-down. Remember, you'll automatically get allocate 27 gigabytes of memory and 3 cores on the CPU when you ask for a GPU. So yeah, as you can see, we have one node, 3 cores. Now we have access to one GPU in the top here. So now when we connect to Jupyter, we just look in a terminal. We see we have access to one MIG instance or one GPU instance on the GPU node, and we can see we have access to 10 gigabytes of memory on the GPU and 16 streaming multiprocessors on the GPU. So then you can just use it if you want to do any training, or if you want to run on the GPU, you can run it from Jupyter here, or any app actually. Because I think nearly every app you're allowed to ask for a GPU. The next application that I wanted to show you is the Trillium desktop. So again, it's the same form as Jupyter. We've asked for 8 hours, 3 cores. Let's ask for a bit more memory. We'll launch that. So this shows roughly the same session card as Jupyter, but we have these two extra options here at the bottom called compression and image quality. This is so based on how fast your internet connection is, I would play around with these. So I'm at the office right now, so I have a fast internet connection. So I normally just have it on high image quality and high compression as well. When we launch, we'll get access to a desktop on the compute node. So we can look, you see around Use 7, and we can look at again, look at the node and see how the process is running. But we can open graphical interfaces here from the desktop. So what I will run here is a GUI application called Octave. So what I'll do is I'll load the modules needed for Octave, and then I will run it in the desktop. So as you can see, this is going to be the hands-on, but I can load again a cosine wave. So the desktop is very handy if you want to run a graphical application, and the application software is available in the CC stack, which is available on Trillium. Again, we can look. I'll just open another terminal. We can use module commands, so you can do module avail, and that'll show you all of the modules that we have available on the cluster. And if you want to, so just take Octave for an example. If we want to run Octave, we'll do module. So ML is just a shorthand for module. We do module spider Octave, we can see that there is one version of Octave installed, 7.2, and it has these dependencies. So then we know we need to preload these module dependencies before we load this Octave module. And that's what I did earlier to run this. But again, if you're used to a desktop environment, either on Windows or whatever, you can open it here in the browser and you can work with the graphical interface. So are there any questions? Because I'll move on to the next hands-on. No questions. Okay. So what I want you to do now, which some of you might already have done, is launch a JupyterLab app and create a new notebook and just plot a sine wave just to show that the JupyterLab is working and you set up with it. So it is 11:17 now. So I'll give you 13 minutes till 11:30 to work on that, and we're here if you have any questions. Let us know if you struggled with that. But I'm just going to go straight on to another hands-on, just for you to get to grips with the Trillium desktop. I want you to launch desktop app and run the Octave example I just showed in the demo. You can use a terminal from the desktop and then load the modules with the module commands I showed. If so, this this relied on the module browser to actually function. So I'll give you the module command. Actually, no, that's wrong. It should be module load. There's a missing load here. So I'll give you 5 minutes to do that, and we're here if you have any problems. Let us know if you had any issues. Okay, good. I'll move on to the next part of the talk. Are you able to start the recording again, Francis? Thanks. So yeah, we're going to look at job submission and how to monitor those. So up to now, I've looked at the interactive app. So this is Jupyter and Trillium desktops. These are all running on the OOD compute nodes. Now, if you have a task that requires more compute resources than what is provided by the OOD compute nodes, you'll have to run your job directly on the Trillium compute nodes, which have access up to 192 cores and 755 gigabytes of memory per node. Remember, I said when you submit a job on Trillium, you get the whole node, so schedule by node rather than core on Open OnDemand. So your job has to use all of the cores on Trillium and a large chunk of the memory. But in order to do this, you need to learn the syntax of Slurm job script and submit the job to the Slurm scheduler. But this can be, again, intimidating for new users, especially the job scripts and getting all of the parameters correct. So In Open On Demand, we've got an easy to understand interface to Slurm called Open Composer. And that's what I'm going to talk about next. So again, it's a graphical interface used to create Slurm job scripts and to submit the scripts to the scheduler. And you can specify all of the job parameters, the resource requests, and any other options through a web form. And we also have templates for common job types such as Python, R, MPI, OpenMP to get you started. So you have a template, and then you can modify the template based on your needs. And it also has a feature to track the status of your submitted jobs via the history tab, which I'll also look at. So to launch Open Composer, you can go through the top navigation bar and click on Jobs. And then if you click on Open Composer, you'll go directly to the front page of that. Or if you know which template you want to use, you can go directly to the template based on your needs. So if you click on just Open Composer, you'll be taken to the front dashboard here. And this will show you all the available job templates. So we have the generic ones. I added a one for VASP and put it under chemistry. But again, I can add more templates here based on your needs if you think it'll be useful. You also have access to the history tab here from the top navigation bar. And again, it'll provide shell access to Trillium and Trillium GPU login nodes from the Open Composer interface. And also a link back to Open On Demand dashboard with a shortcut here and the file browser. But essentially, yes, you'll come here and then you'll find a job template which closely resembles what you want. You click the job template, and what that'll do is it'll take you to the job submission page where you can set up your job. Now, this page is split between your job parameters on the left and then the job script itself, which is what will be submitted to Slurm. And in the parameters section, you can specify the number of nodes, the number of tasks per node, job time limit. So when the job runs, it'll produce output, and you can specify where that output goes, to which file it goes to, and you can also specify the name of the file. You can set email notifications to tell you when the job has started, when it's finished, if it's failed for whatever reason. There are also extra parameters which are specific to the job type, depending on which template you've chosen. So if it's Python, it'll give you a drop down of which version of Python that you want to use. And then MPI, you can choose different MPI libraries if you've chosen the MPI template. And there are also extra fields at the top of the page to the right, which will affect how your job is submitted and where your job is submitted from. So if you go there, you can see that you have a script location. So this specifies where the job script itself will be saved and where your job will run from. And the next section is the script name. So you can give the script a name itself. But remember, when on Trillium, you can't write to your home directory from a job running on a compute node. You have to write to scratch. So just make sure that the script directory is on scratch somewhere. And then the job name. So this specifies what Slurm sees your job as. So the script name and job name are different. Or they can be, it depends on how you want to name them, but this is how it will look in the Slurm job queue. And then the cluster dropdown will change which cluster your job is submitted to. So if you need GPUs, you can change it to Trillium GPU, Otherwise, just leave it as default and it'll submit to the Trillium CPU queue. So I'm going to show in the demo, but the job script is automatically updated based on the parameters you're selecting in the left-hand side, but it can also be edited manually if you want to customize it to your specific needs. So this is what the template look like. So you have the job parameters on the left-hand side with the number of nodes, your number of tasks. You can also change the runtime. But again, this is 24 hours on Trillium, so that's the maximum you can do. If you try and submit a job which is above that, you will get an error, and it'll give you the error and it'll tell you why your job didn't get submitted because you're over the max runtime. You can just come back and edit the form here and then submit it again. This is the standard output from the job. You can change this. The %J in the name of the file here, what Slurm has, it has special characters that you can reference in file names, for example. So what that'll do is it'll create a output file for your Python job, and it'll append the job ID, which is returned by Slurm when you submit the job. So what this does is it stops you overwriting the same output file on subsequent jobs if you're submitting the same job over and over. So you'll have a list in the directory of the each job with the job ID from the output. This is good practice anyway. And then here for the Python template, we have a drop down to change which Python version that we want. And then I talked about the script location, the script name, job name, and cluster. And then this is the script content itself. I think it's just easier just to show you. Actually, I'll do that later in the demo. But you can see as you edit the job parameters on the left, they'll get reflected and updated in the job script on the right. Or you can just click in this box and edit it manually. But remember, if you edit it manually and then you go and change parameters on the left, it may overwrite the changes you've done manually inside the script. So say you've submitted the job, you've filled it all out, you've hit submit, you'll get a little message box at the top saying your job has been successfully submitted, or you'll get an error, and the error will normally tell you what's wrong with your job script. You'll go back and correct it and submit it again. But it'll also give you a link to the history page. So this is the page where after you've submitted a job, you can monitor the status of it, see if it's been queued, if it's running, or if it's finished or failed. Yeah, so I'll give it a status, I'll give you the job ID and other job information. There should be a filter box in the history page, and you can filter by job name or whatever you'd like. There's some few checkboxes there as well. If you click on different columns which have hyperlinks, we'll provide further functionality there. If you click on the job ID, this will open the job in my SciNet, which is a performance. So it basically monitors the performance of a job as it runs, and it'll provide a bunch of performance metrics and graphs to see how much memory you've used, how many cores you're using, along with the network bandwidth and everything related to performance. But just note, if you've submitted a job and you immediately click on that, the My SciNet database won't have been updated, so you might get a not found or not permitted if you click on that link.
Do you know what the sample rate for taking that information is for my sign up?
I think it's been increased to 2 minutes, isn't it, Ramses? I think it's every 2 minutes. So it's not every second, but it's roughly every couple of minutes or something. if you click on the application column, that'll open the job script up back in the editor from the template that you used. Now, if you click on the script location, that'll open the file browser, so you'll be able to look at the location of your job script. You'll be able to open the job script, and there's also a little icon, a little terminal icon, again, which will let you open a shell in that directory on the file system. So this is handy if you click on the script name, because it'll display the job script which has been submitted to Sloan. And if you want to either resubmit that job or slightly modify it, you can click on Load Parameters button, and it'll load that script back into the template again, so you can see all your changes and then do some slight modification and resubmit the job. So we have 12 minutes left, so I think I'll do a quick demo. I do had one more hands-on, but I'll show a quick Open Composer. So we'll go to Open Composer, and then we'll run, I don't know, so we'll run an MPI job. And you can see all of the parameters that we can change here. So as we increase the number of nodes, you can see that the script gets updated dynamically. And if we change the type of modules we want, they'll get updated here. You can change where the job is submitted from and the job name and the script name. So we can change the MPI job demo, and we can change the cluster. So you'll notice when you go to Trillium GPU, you'll get an extra option here called the number of GPUs you want to specify per node. And it automatically added a GPU node option here. If you want 4, it'll add 4. And then if you go back to Trillium, it'll remove that from your script because there's no GPUs on Trillium. So I think the basic one we can run is MPI run host name. The problem is I think Trillium is pretty busy right now, but I'll submit the job. You'll see a job was submitted successfully with the job ID, and we'll go to the history page. And we can see that the job is queued. It'll give you submission time, number. This hasn't been updated yet because I don't think the job is running. But you can see on my previous jobs, you'll see the number of nodes, the number of cores, what partition, because we can have multiple partitions on Trillium. And as you see, if you click here, that'll take you back to the MPI template. If we click on the script location, that'll open the Open OnDemand file browser and show you the script as well as the output from your jobs here. The final thing, yeah, if you click script name, so this is the script that was submitted to Sloan. And then if you click on the load parameters, it'll load the script content up here so that you can modify it or slightly modify it based on what you need to do. Okay, so finally the job is completed. So I can go to the script location and I can just sort by modified. So that is right now. And then we can look at the output of the job. So all I did was I did MPI run hostname, and that just prints per MPI process, it'll print the hostname of the node, and it'll show you a bunch of Slurm job information at the end of it as well. I don't know if there's anything else I wanted to show. You can select a job and delete the info from here, or you can even cancel it as well. You can change the cluster that you're submitting, well, the jobs that you can see from by clicking the checkboxes here. You can change between running, queued, and completed. and the status, so whether it's failed or not. And then you can add other filters in here. So for the last couple of minutes, I had just one more hand on. So if you want to try out Open Composer the next couple of minutes, let's say 3 minutes, 5 minutes just to finish the talk off, and let us know if you can submit a job to Trillium or Teach if you're logged in on Teach. With the interest of time, we've got 5 minutes left. I just wanted to submit a queue. Okay, good. Trillium's a bit busy right now, so it might be a little bit of time before your job runs. We decrease the time to like an hour, it has more likely to run rather than if you said 24 hours, but hopefully that'll run soon. But yeah, this is what your job script should look like in Open Composer. So I just wanted to end with, please, give it a try, and let us know what you think. Well, we welcome feedback and we're open to suggestions for improvement, any new interactive applications that you want to use in your workflow, please let us know. Or any other features that Open OnDemand provides, we can add it for you. But to summarize, we've introduced Open OnDemand as an alternative to our terminal-based approach, which is typical for HPC resources. It's a web-based interface, holographical, and there's no need to install any software locally. That's all remote on our system. It's great for new users who are not used to HPC or terminals, but it can also be used for teaching other tools as well. So if your students don't have access to any HPC resources, we have a teach cluster that you can ask for, and we'll give you some time on it. And it just reduces the setup costs because there's no SSH key configuration that you need to set up. It's all done through the browser. And we've gone through the key features and we've shown how it can be more accessible to new users. We've demoed the SciNet Open OnDemand poll and showed the applications available. And we've showed how we can manage files, run interactive applications like Jupyter and desktop jobs, and also how to submit Slurm jobs via the Open Composer interface to Trillium, and then how to monitor those jobs in the history page. If you have any questions about today's talk or any comments, please email support@scinet.utoronto.ca and we'll be happy to answer your queries. But